I'm Anisha Vyas and I'm a university assistant at TU Graz, situated in Austria. Before that, I was in Sweden where I completed my master's over there. And currently I'm related to the HOTZYMES project wherein I'm appointed as a PhD student at TU Graz. And the current project that I'm working on is simultaneous activation of a one-pot synthesis using alternating magnetic field. So TU Graz is a partner in the whole consortium of HOTZYMES, and I'm appointed as a PhD student in the project itself. So currently at TU Graz, we are working with the simultaneous activation of one-pot enzymatic synthesis. So wherein we are working with different enzymes in one pot and trying to optimize conditions in a way that the enzymes in one pot can synthesize desired products at different temperatures itself. So the enzymes that I'm currently working with are phosphorylases, so sucrose phosphorylase and cellobiose phosphorylase, and the end product or desired product is cellobiose, which is a disaccharide, dimeric oligosaccharide, and currently I'll be working with the process wherein these enzymes are immobilized onto nanoparticles. These are magnetic nanoparticles which are then subjected to alternating magnetic field, and in the end the cascade would yield this industrially important product which is cellobiose. Using one-pot synthesis, we generally synthesize cellobiose by using the other two enzymes that I mentioned earlier, which are two phosphorylases. So starting from sucrose, these phosphorylases in the presence of phosphate convert sucrose to glucose 1-phosphate, wherein this intermediate product is then used by the second enzyme, and which yields in this polymerization of two glucose molecules, and you get cellobiose in the end. So cellobiose in general is an important industrial compound which is directly used in beverage industry, sausage and meat industry, also in pharmaceuticals to a certain extent, wherein it's used in pills encapsulation. So it's an important disaccharide in a way, wherein it can also be used as a substitute to sucrose because it's less sweeter in sucrose, and that's sort of a desirable factor in the industrial processes these days, especially when you're making beverages or food products. So that's the major role of cellobiose in industrial area. So our role in the HOTZYMES project is to basically have this one-pot system wherein we have two different enzymes working at two different optimum temperatures, and in order to nano-actuate this system wherein we have an alternating magnetic field that's applied in order to heat up these nanoparticles, which indirectly are heating up the enzyme molecules. And in a way, you can have this one-pot system wherein you have two different enzymes and different optimum temperatures. And currently, my focus in HOTZYMES is to immobilize the enzymes. And this is definitely important, as to in an industry, you don't want to make the best out of whatever you have in terms of cost. So that would pose a big advantage when constructing the AMF bioreactor, and would be an important advantage of it.